All right, you guys, let's get started with our math lesson today. As always, let's do our I'm a mathematician shout out. So let's begin. I'm a mathematician.
I'm a mathematician.
You're a mathematician.
You're a mathematician.
We're all mathematicians.
We're all mathematicians.
Beautiful. So I do expect you guys to be on voice level 0, face forward, eyes on the board, and Mrs. Avery the entire time. If we have a question, you're just going to raise your hand, okay? So let's review our key points. Well, actually, first of all, today we're going to be generating equivalent fractions using multiplication and area models. So I need a volunteer to read our objective. Let's get Angela.
Our objective today is students will be able to explain why fractions are equivalent using multiplication and visual fraction model limited to fractions with denominators 2, 3, 4, 5, 6, 8, 10, 12, and 100.
That was beautiful, thank you. Alrighty, so let's go over our key points. Let me get this out of the way. So the what? What is this, Mrs. Avery? So we're going to be generating equivalent fractions, which are fractions that have different numbers in them, but they have the same value. For example, 2/4 is equivalent to 1/2. We're going to be generating equivalent fractions by multiplying the numerator, or the top part of the fraction, and the denominator, which is the bottom part of a fraction, by the same number. We're also going to be using area models, or a rectangular visual model that helps us to solve ratios, addition, subtraction, and multiplication problems. We're going to be using one of those to justify why multiplying the numerator and the denominator by the same number generates equivalent fractions. Well, why are we doing this, Mrs. Avery? Let's find out. Daryl, tell us why we're doing this. Right here.
Because the lesson will give us the opportunity to practice math skills that will help us find equivalent fractions before we move on to more abstract problems in future lessons.
Wonderful. Janiyah, can you read our first how?
To find equivalent fractions, we multiply the denominator and
We multiply the numerator.
and denominator by the same number.
Very good. Let me get Jade. Can you read our how number 2?
To solve using an area model.
Step number 1.
Step number 1. Draw an area model representing the denominator with visual lines.
Vertical lines.
Vertical lines. Shade in your numerator. Number 2. Draw
Horizontal.
dotted lines across the area model to multiply. 3. Number 3. Count the new units.
All right. So check it out. We have our anchor chart right here. It tells us how we're going to solve or how to find equivalent fractions using an equation. It gives you a little example. To remind you, we multiply the numerator and the denominator by the same number. To solve using the area model, we follow these 3 simple steps, okay? Step number 1, we're going to draw an area model right here representing the denominator with vertical lines. Then we shade in our numerator. Step number 2, we draw horizontal lines across the area model to multiply. And basically what that means is if you multiply it by 2, you're going to kind of cut it in half long-wise, okay? If you multiply it by 3, you're going to have 3 different horizontal lines on it, okay? And then for step number 3, we're going to count our new units to see if our model matches our equation. Alrighty, let's move on. So during our lesson today, we are going to be using whiteboards to work out some problems together. Let me quickly remind you how we use our whiteboards. Here it is. All right, so when I say go, you have 30 silent seconds to uncap your markers and write down the answer to whatever I ask you. So, just to remind you, we do write big. Mrs. Avery's eyes are not amazing. You can see, got the glasses. We're gonna write really big, just like this, okay? So, let's get ready. Wait a second, class. How do we write? Big. Awesome, perfect. So let's get ready. So, when you're done writing, the caps go back on your markers and then they go back in place. Place is this little groove at the tops of your desks, okay? Where's place? Point. Perfect. Alrighty, so when I say go, you have 30 silent seconds to write yes or no. And remember, it is up on 1. It is up on what?
1.
Perfect. And go. Coming back in 5, 4, 3, 2, 1. Perfect. I like Peyton's. He said no with a question mark. He was like, I don't know. All right. Perfect. Okay, let's get into it, guys. So, I have a feeling that I might need your help. All right. Thank you, Director, for your help. So, like I was saying, please follow along using your personal whiteboards, and please remember I will be using a cold call today. So, one of the main concepts to understand about equivalent fractions is that equivalent fractions all represent the same value even if they look different. So, for example, you have a cake and it's cut into 2 equal pieces. And if you eat 1 piece, you've still eaten half of the cake. You see how it's in 2 different pieces? If you cut it into 8 equal pieces and you eat 4 of them, you've eaten half of the cake. So, these are equivalent fractions. And this section explains equivalent fractions in more detail. So, you could have, for example, 1 over 2, 2 over 4, 3 over 6, and 4 over 8. But if you compare the shaded region to the whole, you can see that they all represent the exact same value. So in fact, they're all equivalent to 1/2, and if you were to put that in your calculator, it would equal 0.5. So here we are. Our check for understanding pit stop number 1. What do you notice is the same about these fractions? No hands? We're going to take 10 silent thinking seconds to think about our answer. Coming back in 3, 2, 1. What do you notice is the same about these fractions? Jade.
Some of them are equivalent fractions.
Okay, yeah? Tell me more. How do you know?
Because I don't really know.
Oh, that's okay. That's not a problem. Let's ask Christian. What is the same about these fractions?
They're multiples of 2.
Okay, yeah, absolutely. Can you tell me what's different? No. No worries. Does anybody want to add on to what Christian and Jade had to say? So I want to know, what do you notice is the same about these fractions? Dara, what's the same about these fractions?
The way they assumes that they are equivalent to 1/2.
Okay, how can you tell?
Because 36 equals 1/2, 6 plus equals 1/2, and 1/2 equals 7/14.
Amazing. All right, can you tell me what's different?
The way they're different is that they have different rules.
Okay. Okay, Anna, what do you notice is the same about these fractions?
That every time you multiply it by 2, the denominator gets bigger.
Just the denominator?
And the numerator too.
Okay, what's different?
That what 1/2 is equal to is different, so and the units are all bigger than 1/2.
Okay. Alrighty, so the correct answer is the way that these fractions are the same is that they are all equivalent fractions that equal 1/2. What makes them different is that each equivalent fraction was represented as a different multiple of the same amount. So, to find equivalent fractions, we multiply the numerator and the denominator by the same number, but we can do this 2 different ways. So, today I'm going to be showing you how to do it. So, number 1, we can do it by solving an equation, and number 2, we can do it by drawing an area model. So, follow along with me using your personal whiteboards. If you get stuck, check out the anchor chart. Okay, so today we're going to be finding the equivalent fraction to 2/3. And I think just to keep it really simple, I'm going to find a multiple of 2. So taking a look at my anchor chart, I kind of have an example of how this is supposed to be set up. So I'm going to rewrite 2/3. And I can see over here that right after that, there's an equal sign. Is everybody following along?
Yes.
Excellent. Okay. And then right after that, I'm just going to draw this long line. And what I noticed over here is that I repeated the 1/2. I wrote it very close together after that equal sign. So what I'm going to do over here is write my 2/3. The next thing I know I want to do is I want to find the multiple of it times 2. So I'm going to use my multiplication symbol. It looks like an X. And so here's my top, 2 times 2. And I know that in order to solve this using an equation, I have to multiply the numerator and the denominator by the same number. So I can't stop here. So here we have 2 times 2, and now we need to find 3 times 2. After that, I think I see that I put another equal sign, and now I gotta figure this out. So I'm a little rusty with my math facts. Renila, what's 2 times 2?
4.
Beautiful. Caleb, what's 3 times 2?
6.
Awesome. Okay. So, do we think 2/3 is equivalent to 4/6? Yeah, absolutely. We followed the directions. We took a look at our anchor chart. It asked us to multiply the numerator and the denominator by the same number. That's what we did. It looks great to me. Let's move on. So, here we go. Let me clear my board. We have another pit stop. All right, so this time I want us to use our whiteboards to answer this question. So erase your whiteboards. Let's get them nice and clean. Our markers should be in place with the caps on. Awesome. So, my question for you is, alrighty guys, sorry for the technical difficulties. So, can you multiply just the denominator and still get a correct equivalent fraction? You have 30 silent seconds. Go. Coming back in 5, 4, 3, 2, 1. Awesome. Okay, so I have got a ton of no's. I don't think I have a single yes in the building. What's your question, Lindsay? Oh, okay. Just a minute, maybe. All right. So, London, why did you say no?
Because if you multiply with the denominator, you're going to get the wrong answer.
How do you know that?
Because it has to stay the same number. And if you times it, then the numerator will not be.
Okay. W, why did you answer no?
Because you have to multiply both the numerator and denominator, or else you'll get the wrong answer.
Okay, how do you know that?
Because imagine if you have the fraction 4/6 and you're trying to find an equivalent fraction.
Okay.
If you multiply only the denominator by 2, then you will get 4/12.
Yeah. You're right about that.
Wrong.
Lamarcus, why did you answer no?
Because, if you multiply 2/3 times 2 times 2, and you maybe get the wrong answer.
How would you get the wrong answer?
Because maybe if it was a quiz, and then if you didn't know what to do, maybe
Oh, keep going. You're on the right track. That's okay, we're done sharing? That's okay, no worries. So, the correct answer was no. The reason is, when you don't multiply the numerator and the denominator, you increase the whole without increasing the part, which will leave you with a fraction that is smaller, not equivalent. So, let's work out an example of why this doesn't work. We're going to use our current fraction to test this. So, previously we multiplied 2/3 by 2. So let's keep that train rolling. So let's find out what happens if we only multiply the denominator. You can follow along with me on your whiteboards. Thank you. So I know from looking at my anchor chart how I'm supposed to set this up. But instead of multiplying the numerator, I'm going to leave that alone and see what happens. So if I'm not touching it, I'm just going to move it over. All right? And now we've got our denominator. And just like before, we're going to multiply that by 2. Well, let's see what happens. So if we do nothing to the 2, once again, I guess I'm just going to move that over. Let's see who knows their math facts. Okay, Anna, what's 3 times 2?
6.
6. All right. So it looks like this is what I get. So I have 2/3 equals 2/5. over 6. Does this look right?
No.
No. Why don't I get 4 over 6? Renila, why don't I get 4 over 6?
Because you did not times 2 on the numerator.
Well, I mean, aren't they still equivalent? I mean, isn't 2/3 equals to 2/6 still equivalent?
No.
No. Okay. Tell me more. Why aren't they equivalent?
Why it's not equivalent? Because you're supposed to have another number on the numerator. Because if you had the same number, it would be wrong.
On the numerator or the denominator? The numerator. Okay. Who else thinks this isn't right? Bailey.
I think it isn't right because you always have to multiply the number on the numerator by the number that you multiply the denominator by,
Okay.
so that it can be easier.
How is this not equivalent though?
Because when we did it earlier, we have 4 over 6 and now we have 2 over 6 because we didn't do it right.
Well, you're right. We definitely didn't follow the steps. But how is 2 over 3 not equivalent to 2 over 6, Peyton?
It's not equivalent because you have two thirds and 2/6, and say if you wanted like to times, or say if you wanted like to divide, if I divided 6 by 2, that would be 3 I meant, and then if I did 2 divided 2, that would be 1, and that would turn into 1/3.
Wow, you worked that backwards. That was pretty good.
If I'm right.
Yeah, well, you all were right. They're not equivalent. But let me tell you how they're not equivalent, okay? 2 over 6 is smaller than 2 over 3. Let's take a look at this. 6 and 3 are my whole. Is 3 the same as 6? No, not at all. If we're trying to find an equivalent fraction, this is a multiple of 6. Or 3 is a multiple of 6. Or no, what? I've lost my mind. Please forgive me. 6 is a multiple of 3. The whole got bigger, which would normally be fine, but our part didn't change, right? We still only have 2 tiny parts out of a whole that's just now been increased. And that is what makes them not equivalent. So, now let's move on. We're gonna solve by drawing an area model. So don't forget, the reason why we use models to help us solve equations is because they can visually show us how to solve problems. So let's use our anchor chart, and we're going to be following the steps. I keep looking for a pen. So I need your help to solve using an area model. What's step number 1, Jaden?
Step number 1, draw an area model representing the denominator with vertical lines. Shade in your numerator.
Okay, let's do that. So here I have my rectangle, my area model, and the first thing I need to do is draw a box. Great. Step 1, or part of it, it's already done. The next thing I need to do is I need to represent my denominator with vertical lines. So what's our denominator?
3.
Excellent. So now I'm going to break this box up into 3 equal parts, just like so. The next thing the instructions are telling me to do is to shade in our numerator. What's our numerator?
2.
Beautiful. So I guess I'll do that now. Da-da-da. Real easy peasy. Step number 2. Jacob.
Step number 2 is draw horizontal lines across the area model to multiply.
Okay. Perfect. So the last time we tried to multiply this, we did it by 2. So let's do that now. Let's see. What color do I use? There we go. So I guess I need to multiply it by 2. So I'm going to look at my model and I'm going to try and break this in half horizontally. So I'm going to go just like this. Can everyone see how I kind of broke this into 2 equal parts using my vertical lines, horizontal lines? Obviously, right? That makes sense. I'm definitely not losing you here. All right, so step number 3, Jade.
Number 3, count your new units.
All right, so now we have to count our new units. I think it's clear that I need to count all of these boxes in order to find my denominator. So let's do that together. 1, 2, 3, 4, 5, 6. 6. So I guess my denominator is 6. And now I need to count my new units for my numerator. Let's do that together. 1, 2. I messed up. Renila, how did I mess up? What did I do wrong?
Because when you're supposed to shade it in, you're supposed to shade in 2 boxes out of 3 boxes, but you want to shade in 1.
I think you're absolutely right. See, I didn't do this right. Do you see how easy it is to mess up these area models? That even Mrs. Avery made a mistake. So let's fix it, okay? This is really easily fixable, okay? So if I was supposed to shade in 2 of my boxes and I only shade in 1, I only need to shade in 1 more box. I'm gonna do that now. Perfect. So let's go back. Obviously our numerator is not gonna be 2 anymore. So I'm gonna erase that. And you're gonna help me count 1 more time. Let's do this together. 1, 2, 3, 4. Boom, baby. 4/6. So now you can see that my area model justifies my multiplication. If you run into this problem, this is an opportunity for you to take a step back and assess, is my area model wrong? Is my multiplication wrong? Right? Our area models help us to justify the equation. Our equation helps us to justify our area models. This is like a backup for each other to make sure that we've done it right. So, very good, everybody. So, now, here comes the fun part. So, I want to hear from you. I want to hear your voice. We're going to work out a problem together, but I want to know what you guys want to see. So, we have 3/8, 2/4, or 4/5. And what we're going to do is we are going to work out these problems finding a multiple using an equation and with an area model. So, I want you to vote. You're going to come up to the board and you're going to choose if you want to multiply it by 2, multiply it by 3, or multiply it by 4. So we're either going to double it, triple it, or quadruple it. When you come to the board, I just want you to write a D, a T, or a Q over which fraction you want to find the multiple of. So starting with row number 1, let's get Jacob, Kiana, Daryl, Jaden, Jade, and Bailey. Let's get to the front. Yeah, let's go on up there. Pick which one you want to double, triple, or quadruple. All right, when you're done, have a seat. Okay. So let me get row number 2. That's Peyton and Lauren, Janaya and Netio. Lamarcus, you're next. And then Christian. Oh my gosh, we really want to quadruple this stuff. All right.